Hi everyone, this is a video and I'm going to be talking about 2.3. So you might be aware that 2.3 is on quadratic functions, and in the previous section we called x squared the squared function, one of the basic elementary functions. So you see here's a picture. The shape we call this is a parabola. Right? So it looks like a U, or it could look reflected downward like an N, okay, depending on if it's So there's a negative x squared there. So the graph of every function for a parabola, right? The most extensive you could write it, the shortest would be just x squared. But if you want to be, extra, you could have it where it's in this format. And you might have seen this before, where it's f of x is ax squared plus bx plus c. So you notice 1x is squared, 1x is not, and then there's that c term that doesn't have any x with it. So these make up various parabolas for various a, b's, and c's. And you want to think a cannot be 0. If a is 0, then you won't have a quadratic, you'll have a linear function. And this is what we call standard form. So you could practice with some of the ones that you see on your homework. You could just type it in and you'll see a quadratic. So for instance, if we go to Desmos and I just type in the following, let's see, f of x equals x squared minus 4x plus 14. We see where's the quadratic, so we need to zoom out a bit, but we see it's up here, right there. Okay, remember you can zoom in and zoom out with these plus and minuses. And if you're on an iPad, you can use your fingers to zoom in and out. And if you have a mouse, you can drag and position it how you would like. Oh, no, not this. Okay, so back to the notes here, Joe. Don't forget, this is standard form, okay? So what is the domain of any quadratic? All reals. Or you can think interval notation, negative infinity to infinity, okay? So all real numbers. So there is a concept that if you wanted to find the 0 of a function, or we call the x-intercept, so where it crosses the x-axis. So we'd use something called the quadratic formula. So what this says is if you have a quadratic equal to 0, and remember, if it equals 0, that means your output or your y value would be 0. So therefore, it's where you cross the x-axis because that is where y is 0. Then how would you solve this, right? So you probably have done this many, many times in high school. You use the quadratic formula to solve a quadratic for when it equals 0. And that is the equation there. Okay. So you can do this if you'd like for some of the homework questions if you have to find the x-intercept. Okay. So for this first one here, it says it wants you to sketch a graph. So I'm sure you've used to plotting points. So I would just say for something like this, you could create a table if you'd like. You could do, what they did before and fill it in. But since we are so used to Desmos, I would say use Desmos. Get used to using this tool, especially if you're going to take Math 120. Desmos will be used in that course as well. So let's plot this on Desmos, see what it looks like. Right, so we have negative x squared plus 5x plus 3. I can double check real quick to see if that was right. And it is. All right, so we see it looks like this sort of graph here. Okay. So to get this general shape, one thing to notice is if you're plotting points, you have to make sure you plug in the right points, which can be difficult, right? So if I plugged in just -2 to 2, I'm only going to see looks like a straight line, right? So that's why I emphasize Desmos. Plot your graph on Desmos, see the general shape, and we can determine some things about this graph, okay? So if we click on it, some things are highlighted, like this point at the top. We're going to say that's the vertex, okay? So the point at where the quadratic turns. There's other ways to label the vertex as well, or to quantify the vertex. We have the y-intercept here, and these two at the bottom are the x-intercepts, where we cross the x-axis. So you could get these two values, the -0.541 and the 5.541, by using the quadratic formula as well. And I'll show you that in a second, just so if you're curious, okay? So it says here we need to find, right? So you want to think x-intercepts. The goal is to use, okay. So one thing I will say is that one approach is you just use Desmos. And as you saw, Desmos will identify your intercepts, okay, and your vertex. We'll talk about the vertex a little bit later. And you see that as what part C is doing, okay? But if you just want to use Desmos to do everything, perfectly fine, okay? The second approach is you do by hand, okay? Which means for the x-intercept, you want to use the quadratic formula. And then for the y-intercept, that is just find f of 0. So that is the y value when x is 0. So if we plug that in, you'll see here that this would just be, so f of 0 would be -0 all squared plus 5 times 0 plus 3. So if we simplify this, I get 0 for the first term, plus 0 plus 3, so I get 3. So this tells me that I go through 0, 3. So this is your y-intercept, because remember the y-intercept is the y value when x is 0, but we saw that on the graph already. And then for the x, if you want to use the quadratic formula, remember you have to identify your a, which is the coefficient of, or what's in front of the x squared, so that's a -1. Your b, what's in front of the x term, because remember, it's going to have this format here, and then our c. And then we need to plug it in -b plus or minus square root b squared minus 4ac all over 2a. So you can sing it like that. There are a lot of YouTube various songs by famous singers that have the quadratic formula. Maybe in high school you had to make up one or memorize it that way. But as I said, in this course, you'll never have to do that. You know, everything is open book, open notes. You can use Desmos, you can use the internet, whatever you see fit. But it has to be your own work. So let's plug everything in. So x equals -5 plus minus square root of 5 squared minus 4 times -1 times 3 all over 2 times -1. So we're going to simplify inside the square root first. So that would be 25. And then that second term will actually be a plus 12. Okay. And then all over -2. And then we get x equals -5 plus or minus 37 over -2. And then you'll get two results here. One with the plus on the top. And then you'll get one with the minus on the top. Okay. And what would these be? So that's when we need Desmos to see what those values are. So let's switch over to Desmos. Let's type these in. So if I had that parentheses, -5, or I could do it the other way. I'll show you. So you just go here, you do division, you have a fraction, so then type in the top, and then type in the minus 2. And we see we get that negative, okay? So then you see we get the negative 0.54. We could do the same thing, do your division to get your fraction, and then negative 5, and minus square root of 37 all over minus 2. And we get the 5.51. Okay, so we see we get these two values here. So practice with Desmos with computing these. Sometimes MATLAB wants you to put exact answers. So these on the side here with the square roots would be exact. So I'll go back over to the notes. So this is, so let's see, the plus one was, okay, got it. Negative 0.541, 5.541. I think that had a negative. Let me check, and it does not. Okay. The other one, 3. So you're aware this would be the exact, and this is an approximation. Right? So make sure you understand if the question wants exact x-intercepts, do the quadratic formula, simplify it down. If it wants approximate, you can use Desmos because we got these values. Okay. Or you can also look at the graph. Okay, so you could practice with that. Okay, so it says find the intercepts graphically. So that's just graphing at Desmos. Where does it cross the, remember, x-intercept is across the y-axis, which is the vertical axis. And remember, x-intercepts is where it crosses the x-axis, which is the horizontal axis, okay? So moving on, you could do this match problem here to kind of quantify your understanding, see if you get the same result at the end. So practice. All right. So next is vertex form. So you want to think, we see that we talked about standard form here, and we could do some magic or some mathematics, and we can transform it to this. So what I'm saying is you take this standard form and you transform with math to this vertex form. Right? And why are we doing that a vertex? So because in this format here, in this format right here, so this is a quadratic with a vertex at this ordered pair. You'll see it's HK, so whatever is on the inside is opposite, outside is the same. Okay, so the H is on the inside, it's opposite, K is on the outside, it's plus, so it's the same. Okay, so for instance, if we wanted to look at this, and I wanted to get the vertex form, well, first I have to do a technique called completing the square. Okay, and this is a very troublesome way to do it because you have that value in front, and one thing to note is it gets this for completing the square. Okay, how do they get that? It's a very complicated process. So we'll do an easier one where you don't have a number in front of your x squared, you have just a 1, and then we'll do this one. So let's say, suppose you have this, and you want to complete the square. Okay, so it looks like if you look at the vertex form, you have x minus h all squared, and then you add something after that. So it looks like we're factoring this out. But how do we factor this? And we want it to be where it's double because it has that x minus h squared. So we have to, trick the equation. So if you think about it, what we're going to do is we're going to take this middle term, we're going to cut in half. So that means the negative 4 is now 2, then you square this value. So the negative 2 is now 4. Okay? So then you add, put this in quotation marks, and subtract this value on the same side. So what I'm saying is if I have this, take half of negative 4, which is negative 2. I square that, and I get a positive 4. So I'm going to add that, and then I'm going to subtract it. And then I'm going to have my 14. So these are the two things I added and subtracted. And now you'll notice if I look at just this first part here, I can simplify this. It's a perfect square. So if I factor these first three terms here, I get x minus 2 all squared. Right? If you want to think, what's the shortcut? Well, minus 2, oh, it looks like what we have right here, right? It's the negative 4 cut in half. Okay. And then what about on the end? So the end here, I'm going to take these two terms, add them together, and I get what? I get plus 10. So this is my vertex form. Okay. So completing the square can be tricky. So in the past, students have struggled with this a lot. We don't really see it that often. We see it in this section, and we won't really see it much again because in this course we can use Desmos to graph things. Okay. And one thing I will say is if you can graph your equation, you can actually get the vertex and then write it without having to do completing the square, and you'll see what I mean. Okay. So what this says here, if I take this equation, right, I'll show you what I mean. I can graph this, right? So let's graph it. So I'm going to graph the original one. Right? So if I graph the original one, I'm going to do y equals x squared minus 4x plus 14. So it looks like it's a quadratic, right? Where's the vertex? It's right there at 2, 10. So now I'm just going to rewrite, okay? So y equals, and one thing to know, when you do vertex form, the a comes first. So in the first one, a is 1, so I'm just going to put a 1 there, or we don't need to put it, so I won't put it, okay? And then parentheses, x minus 2, close parentheses squared, and then I have to add 10, because that's where our vertex is at 2, 10. You see they now have overlapped because they are the same equation. So as I said, doing vertex form, one method is, so standard to vertex. One method is you complete the square. The second method is you graph, you find the vertex, and then write equation with a. Remember, a is from your standard form, and your hk, which is, remember, this is your vertex. So let's practice the second method with this one right here. Now, some of these other questions on your homework, some of it's already given it to you in that format, and some of the questions on the homework will say, here's a graph. Let's see if we can get the vertex form, okay? So I do find out that in the past, completing the square can be quite problematic because it's just a very meticulous process. So let's see if we graph this, can we arrive at the same thing using this second method here? Right, so negative 3x squared plus 6x minus 1. So y equals negative 3x squared plus 6x minus 1. So we see it's right here. Okay, so just remember, what's the vertex? We graphed it. The vertex is at 1, 2. All right, so let's say we forgot to include our A, what would happen? So if I just put that 1, 2, so remember it's going to be, since it's 1, 2, it's going to be x minus 1. Okay, it's always the opposite for that first number in your vertex. Square it, and then plus 2. What do you notice? It's not the same, but it has the same vertex. So to get it, if it opens up, for it to shrink or stretch, that's what the A does in front. So we can go back now, and in front, our A needs to be the same as our A in the standard form, which was minus 3 because it's in front of the squared. So we put that there, and now they line up exactly. So please use Desmos for this. I feel in the past this has helped a lot of students. They like this sort of approach because you don't spend hours and hours trying to complete the square. So Desmos is your friend. Okay. So for this next part here, it just wants you to talk about you use completing the square, or we can say, or Desmos. Okay. So the vertex of the parabola is at the point. And this one is at the point 1, 2. Okay. Where f of 1 equals 2. And this is the, let me make sure I use the right vocab here. Give me a second. I want to make sure I don't say the incorrect thing, because I know some of these can be a little tricky. Let me. Okay. Because then we'll have a little bit other things to say, but I'm trying to make sure. Okay. So in this problem, they're saying that f of 1 equals 2. We saw that in the Desmos, that this is the maximum. Right, so it's the max value for the whole function. Okay. So the function value corresponds to any two values at the same distance from 1 are equal, which is true. So if you looked at f of 6 and f of negative 5, you'll see 6 and negative 5 are the same distance from 1. Okay, so they're both compared. Each of these values is, I think there's actually a typo here. This should not be it should be minus 4. Okay, this book's getting a little bit ahead of itself. Right. So what it's saying here is that if you take any two values that are the same distance for the left and to the right, you'll get the same y value. Okay, so the line x equals 1 is a vertical line and is the line of symmetry. So that means I could cut the parabola in half and it would be a mirror reflection. Okay. You could draw the line on the graph, and we can do it on Desmos right now. So on here, Desmos, if I go here, if I type x equals 1, I have that vertical line, and you see it cuts that parabola in half nicely. Okay. So moving on, you'll see there's a graph here. It talks about some other things, about the range. Okay, so remember, if we look at a graph here, we see that, well, I'm going down and to the left and to the right. So the domain, just to practice, remember this is a quadratic, so all real numbers. The range depends. So this, you think this opens downward. So we're going to say it's going to be y is less than or equal to the max value. So the max value is right here. So that is at 2. Or if you want to do interval notation, anything less than 2. Okay. So some things here, it talks about it. You'll see it mentions it here. And then talks about, this was our standard form. This was our vertex. And how if A is less than 0, it's going to reflect in the x-axis, so it opens downward, so it doesn't look like a U, it looks like an N, and we see that up here. It looks like an N or a mountain. Okay. And this kind of just summarizes a lot of things. So for this first one here, just make note, A is positive, so it opens upward. This one, A is negative. It has your axis of symmetry up here as x equals h for each one. It has your vertex, right? And it says this is the max, and it says this would have a min. Okay, so just utilize this if you need to. Okay. So for this next one here, and you will have some questions on your homework, it will give you an equation, either in standard form like this or vertex form, and you have to answer quite a few questions. So I would suggest the first thing that you do is you graph the equation. Okay, you can use Desmos, don't worry about that. Okay, so graph first. So let's look at this graph. We need the vertex, max or min, describe some transformations that were used, and then sketch. We'll just sketch a graph first. So 0.5x squared minus 6x plus 21. Okay, so let's just type that in up here. Y equals 0.5x squared minus 6x plus 21. Was that it? Let me check back. Okay, so what's the vertex? When we see that from Desmos, we automatically see the vertex is where? It's right there. It's 6,3. Okay, so I keyed it in. Just click on it. It'll tell you the vertex and any intercept. So here's a y-intercept of 0, 21, or 21 is the y-intercept. You'll notice it never crosses the x-axis because it's opening up and it's already above the x-axis. So there are no x-intercepts here. So we know that the vertex is at 6,3. Okay. And we want to do what? This is a min. Okay. And then that means the range would be y is greater than or equal to the y value of your vertex. If it's a max, it's y is less than or equal to, like in the previous problem. Okay. So this wants you to find vertex form, which can be tricky. But remember, we just talked about it, right? So what's our a here? It's 0.5. And we have our vertex. So let's write it together. So f of x equals 0.5 parentheses x, and then remember opposite of the first one, so minus 6 squared, and then plus 3. Right? And this would be your vertex form. We could check that. Okay, so let's go back and check. So y equals 0.5 parentheses x minus 6 parentheses squared plus 3. And they line up exactly. Okay, you'll see here that same color. So one thing to note is that for some of these, like for this one, if you want to use completing the square, it can get very complicated because you have that a in front. Okay, and looking through the homework questions, there aren't any that require you to know that or to have a is greater than. I'm double checking because I think I did get rid of those, because trust me, they are not fun in any way. Okay. Yeah, and it seems to be all right from what I'm gathering right here. Okay. So, describe how the graph can be obtained by using transformations. So remember, typically the vertex is what? For the x squared is at 0, 0. And it's going to look like this. And we see that our graph, looks like this, but it's at 6, 3. So that means we did what? We went right 6, we went up 3. Because if you take 0, 0, you have to go right 6 and up 3. Okay, but remember, this is x squared, and this is 0.5. So then we have to do what? We're vertical shrink by, in this case, this is your A. So your A will always shrink. Since it's less than 1, it shrinks it, okay, between 0 and 1. We already sketched it on Desmos. You could do a practice problem, okay, match problem too. A lot of these E and F, I want you to graph it and do it that way, but I would just suggest graphing it at the beginning, just getting you used to graphing with Desmos. So now we will go to the word problem. So there will be a few word problems in your MyLab, I think 1 or 2 maybe. And it deals with, so it won't really deal with example 3 here. You can work through it if you want, but I will just mention that the next example is going to be what you see on your MyLab, not really example 3 that much. So it just to kind of go over some things, refresh your memory. This is your price demand. If I take it, multiply by X, I get what? My revenue function. And now if I graph that, that looks like a quadratic, okay? Like, oh, this is the section with quadratics. Okay, so that's why it's focused on here. So this wants you to find the max revenue to the nearest $1,000. What you want to do, graph on Desmos. Okay, and look for that max, that peak. Okay, you'll notice in this case, your x squared term is going to be -5, so it will have a max. Okay. So for this part, it wants the wholesale price that generates the max revenue. So what is the wholesale price? Well, the wholesale price is from your tiny p of x equation and your revenue. Okay, so let's figure out what that would be. So the max revenue happens when x equals what value? So let's look at that graph. Okay, so x parentheses 94.8 minus 5x. Okay, so y equals x parentheses 94.8 minus 5x. And you might think, oh boy, it's hard for me to see it. I see 2 lines. So what you want to do is we need to modify it a bit. So I'm going to zoom over to look like this. And then I'm going to click on the wrench here. And I need to change my y-axis to be a larger number. So let's just put 150 there. I still don't see the top part, so let's make it a little bit bigger. Let's make it 300. Still don't see it. Let's just go and say 1,000. Oh, so we see the graph now, okay? And then we click on it, we see our max is at 9.48 and then 49.35. Okay, so let's go over here. So we got that the vertex for this is 9.48, 49.35. Okay. So this tells me what? This tells me that the revenue will happen when I sell X is what? X million cameras. So max revenue happens when I sell 9.48 million cameras, which is how many cameras? A lot, right? So it'd be, if I could do that, multiply it out, but I'm a little tired right now. So we're just going to say this is how many cameras, okay? So if you wanted how many cameras, you have to type a lot of zeros. Just think multiply that by a million to get the number of cameras. And this tells me the max revenue in what? Millions of dollars. So almost half a billion, okay? Almost. So how would I get the wholesale price? So what does that mean is I need to figure out, well, how many cameras would I need to sell? And then, so evaluate X that gave max revenue in your tiny p of x. So that is 94.8 minus 5 times 90, this. So that's your tiny p of, okay, whatever that would be. So let's go back over to Desmos and see what that would be. So 94.8 minus 5 times 9.48. So 47.4. So remember, P of X is the wholesale price per camera. Okay, so how much would it sell for? So that camera would need to sell for $47. Okay, $40. Right. And then it wants you to graph the two, so you just use Desmos for that. We just looked at that already. And we already found the camera that will generate the max revenue. Okay. And we already found the max revenue. So typically the max revenue will be the Y value of the vertex. And then, okay. And this match problem 3 here is very similar. One thing you'll notice is it throws in what? It throws in cost. Okay. So what it wants you to do is, what's the profit? So remember, profit, which is large P, is revenue minus cost. So in this case, we just take our revenue function and we subtract the cost to get the profit function. So on your homework, you will have a question that asks you that, okay? It's the last one. I want you to write out the P of X, and it says type your answer in standard form, which can be complicated, okay? So, and I think one of these on the mini project video, I don't know if it's for this section or another, but we'll go through it again. So in this case, your revenue was X times 94.8 minus 5X. And then we're going to subtract from it the cost, which is 156. Right, so one thing you note is, how do I simplify this to get it in standard form? So this would be 94.8x minus 5x squared. I'm going to now, so I distributed my x, distribute my negative on the second one here for the cost. And then I need to combine like terms. So the only like terms you have are these two things here. So let's get our calculator, see what we get there. So so I get negative 5x squared, and then I will get plus 75.1x, and then I get minus 156. So this is your profit equation. And then we go through the same thing. I want to get what? I want to get the max profit. What would give me the max profit? What's the wholesale price of the camera to get the max profit? Graph it, and so forth. So we'll just look at the graph real quick. This wants you to complete the square. Yeah, we're not doing that, okay? And the homework question, you don't have to complete the square. So we're not gonna complete the square here. We're just gonna look at the nice equation that we have, because completing the square for this is, you'll notice for the match problem here, if you look at their solution, like they don't even They don't even complete the square. Great, right? Awesome. Okay. Let's see what they have here. Yeah, they do this for completing the square, which is a little silly, and you'll see why. So you don't need to worry about that when you do yours up here. Okay. So let's just look at the graph. Okay, so let me take a picture of this, and then we'll go over to Desmos and look at the graph and talk about a few things. Right, so if I look at this graph on Desmos, right? So I have y equals negative 5x squared plus 75.1x minus 156. If I just go see, oh, well, I can't really see it, so I see some here. So it's the same way before. If you're trying to see the whole graph, you need to change the window. So let's just put 500 for the max and see if we can see it. And we can, so it's right here for your y max, okay? And I see that we get that. So we get that the max profit is around 126 million, okay? And the 7.51 is the amount of cameras. So I don't need to sell 7.51. Remember, this is how many millions of cameras I need to sell to make the highest profit. Okay. So the last part of the notes, okay, talk about, so what is the max profit? So we said it's 7.51. 126 is the vertex. So that means 74.51 million cameras. Give us a max profit of $126 million. Okay. And you could plug in, remember, the 7.51 into your wholesale, your tiny p to get the wholesale price if you would like to do that. Okay. And one thing I will say is that when you're comparing max profit to max revenue, remember revenue, the most revenue you can get versus the most cost, okay, and then the most profit. So when you're thinking of that, just think of it intuitively. If the most revenue is a certain amount of money, right? What would you say? Would you say it's greater than, less than? So just think the profit will always be smaller than the revenue. Okay, the max profit is always smaller than the max revenue. So for this last question here, just a touch base, break even. So if I have my R of X, I have my C of X. If I want to do break even analysis, remember what is this? This is when your revenue equals your cost. So I can graph each on Desmos, see where they intersect. We'll do that in a moment. And I want you to find the break-even points algebraically. We don't have time for that. And one thing, is this 1,000 cameras? Is this, make sure I put million cameras. Is it 1,000 cameras? Let's see. Millions of cameras. Okay. And then down here, thousands of cameras. Well, that's suspicious. Millions of cameras. Oh, this is a hot mess. So as you see here, this should be, not thousands, it should be millions, okay, to match up. So typically whatever your X is and your cost will be the same for your revenue and everything, because they all have to have the same units. This should be millions of cameras, but we're not going to complain. Okay, people make mistakes when they write up these things. So let's just type them on Desmos. Let's type both of these functions on Desmos. I'll take a picture. and we'll see and I'm going to keep the profit up there just so you can be aware of something. Okay. I want you to see the relationship between all three. So now if I go back, so let's see. So remember, the purple line is your profit. I'm going to do my revenue. And then last but not least, I'm going to do my cost. And I want to highlight a few things. You'll notice they intersect here. What's this point? Oh, it's very similar. They intersect there. What's this point? Oh, very similar. Okay. So there is a few places where there could be some, rounding error. Okay. Oh, why do did I type in the wrong thing earlier? Let me check something real quick. I might have, there's a 7. Should that be a 6? Oh, wow. Did I just put a 7 there magically? Oh, it has a 7 here. Okay, great. So don't be alarmed that it's great. They changed the number here. So I'm just going to put it as the same as before. So there is no confusion. I don't know why it slightly changed it, but we're not going to have any of that. So, all right. So one thing I will say now that I've modified it to look nice, you'll notice that these numbers match up exactly. So where they intersect, the break-even point was when the profit was 0. Okay, and likewise up here, these match up exactly. So the break-even point, remember, the cost is the red line, the revenue is the black line. When they have break-even points, that's when the profit is 0. So that's the whole connection here. Your break-even analysis, you're looking for where revenue equals cost. That's when your profit is 0. So between those two break-even points, your profit would be positive. Outside of it would be negative. Okay. And pretty much this is what this last example wants you to do. Okay. So I hope you enjoyed this. Okay. Just think that loss will occur if revenue is less than cost. So that's outside your break-even points. So that's outside your break-even points. And when does the profit occur? Between your break-even points. Okay. So when would it occur a loss outside of those two? Okay. So we could say it would occur a loss less than 2.49 and greater than 12.53, but it'll occur a gain between those two. Okay, so I hope you enjoyed this video. Let me know if you need anything. Look out for the next one. Thanks again.